Okay, well, welcome everybody. So my name is Nikki Watt and this is Brett Mack, and we're going to be talking to you today about building a Terraform provider and using VCD as an example. So really quickly, who we are. So we're a hands-on tech consulting company. We work with a variety of different clients, quite a lot in the sort of DevOps space, and many of our clients make use of HashiCorp products, and we're actually really proud as well to be system integration partners. One of the projects that we're working on is a cloud automation project with the government, and one of the key features that they are looking for in this particular project is how do you go about creating secure, self-contained environments in different clouds. So for example, if you have a developer who wants to spin up an environment to do some testing, spin it up in Amazon or spin it up in Azure or some other cloud provider, how do you go about doing that? There's quite a few HashiCorp products that are actually used in this particular project, but it's also the project that actually gave birth to the VCD provider, which Brett is going to do the majority of the talking about today. So the agenda, really quickly, I'm going to do a Terraform introduction, and then Brett is going to talk about the VCD provider and building a generic Terraform provider. So really quickly, show of hands, who's actually used Terraform or is actively using Terraform? Okay, so a fair number of you. So this is the super quick introduction to Terraform. So Terraform, for those of you who don't know, is a way to basically create, manage, and manipulate infrastructure resources. You do this by defining resources in one or more files, and this pretty much describes the target architecture in your cloud that you're trying to create. You then point Terraform at these files, and when it gets applied, it takes the definitions that you've created and it creates the physical infrastructure resources in the cloud and starts costing you money. These it's also not just a one-off creation tool though. So it's not that you just create it to do to create your VMs for the first time. You can also do it to manage your infrastructure. So let's say, for example, you started with 5 machines, and then you decide, well, actually, I want 10. You can change your definition in your Terraform file, have Terraform reapply it for you, and it will then basically create 10 machines. It can also do things like diffs, so it can say, well, this is what you've asked me to do. The cloud provider's only got 5. I'm going to create 5 machines for you. Do you really want me to go ahead? So it gives you control to be able to deal with that. One of Terraform's key selling points, though, is that it can handle multiple different cloud providers. So as opposed to maybe if you're just in Amazon using something like CloudFormation, or if you were doing something in OpenStack, you might use Heat, you can actually use Terraform to define your infrastructure for both of these cloud providers. And it's also not just cloud providers, so you can use things, you can connect to things like PaaSes, things like Roku and Cloud Foundry, and also software as a service type offerings. So maybe you have a DNS provider that you also want to integrate with. You can do all of this in one place in your Terraform files. Out of the box, Terraform supports pretty much all of the major cloud providers as well as quite a few others. But another one of its key selling points is that it has a pluggable provider architecture. And pretty much what I mean by that is that, you know, if the cloud provider out there isn't currently available in Terraform, Terraform has a wonderful way of giving you an approach and a framework to allow you to build it. And that's pretty much what we've done with the VCD provider. And with that, I'm going to hand over to my colleague Brett, who's going to give you all the good details about that.
Thank you, Nikki. Is this on? Okay. So I'm going to speak about developing a Terraform provider. And I'm going to use VCD as my main point. So what is a provider plugin? Terraform is written in such a way that it's plugin-centric. Every cloud provider that it will deal with is written as a plugin. This makes it really versatile and very easy to develop for. Some of the providers currently out there are listed here. Now this list has grown really, really quickly. When I was first working with Terraform, there was less than half. So chances are, if it's not supported, it will be very soon. This talk is going to mainly concentrate on the VMware vCloud Director, because we at OpenCredo wrote that. I think if I spoke about creating the AWS provider, Mitchell would have something to say. So the first thing you want to do when creating a Terraform provider is work out what it is you want to control. That seems really simple, but too often you go into something and you see everything that your cloud provider can support, and you try to implement it all. That's going to take ages, you're going to get bored, you're going to give up. Also, even if you only want to support a very few amount of features, your issue is not going to be unique to you. Lots of people are going to want to do the same thing. So if you can quickly get that out, other people will be happy, they'll be using what you've written. Also, you need to remember that open source community projects grow naturally. As soon as something is out there, people will contribute, people will work on top of what you've done. So in defining what we want to control, for us it was, I want to spin up some VMs, and I want to control what ports are available externally. So if this was Amazon, I'd be looking at an EC2 resource and a security group resource. However, in VCD, it was not quite that simple. So this is a typical vCloud Director architecture. You have the internet, and from there, the first thing you come into is an edge gateway. Now, your hosting provider will give that to you. You can't control that. That's part of what you're given. However, from there, things get routed to an internal network, rules are applied, and you finally get down to a VApp. So what we need to work on is this. So like I said, we wanted to create a VM. In vCloud Director, that's defined as a VApp. So EC2 would be the same kind of thing. But when a VApp is created, it does not get an external IP address. That VApp cannot communicate with any other VApps, and it can't communicate with the internet. In order to do that, it needs to be connected to an internal network. So that's another resource we need to write. Now, you're going to have multiple VApps all using the same external IP now. So in order to route things through to the right VApp, you need to create destination NAT. So now our 2 resources are now 4 resources. And lastly, for them to be able to connect outside to the internet, they need a source NAT. So our 2 resources are now 5 resources. Now we know what it is that we want to create, we need to look at core Terraform provider concepts. First of all, you create a file, a provider file. Now, this is going to be the core. Right here, you define what it is, or how it is. You make an API connection to the hosting provider you want to work with. What resources this provider will support. And that brings us on to resources. So, like we said a minute ago, there are 5 resources we need to work with. So we're going to have to create 5 separate files, 5 functions, and we need to put that, say in the provider what they are. Now, once you have your provider and your resources, both of these are defined with schema. So schema is going to be your user-defined attributes that you can accept, or maybe attributes supplied back to you by your API. Once you have that, you wrap everything in a plugin. This is really easy with Terraform. It's 3 lines of code to wrap everything you have and create a binary. Now, it's important to remember that everything in Terraform is its own binary file. The way Terraform works with these binaries is if we look at our Terraform VM, really small file, when it sees provider VCD, Terraform is going to launch the provider binary that you've created. When that binary launches, it's going to look at the preferred method of communication for the operating system it's running on. Now, on Windows, that's going to be opening a port and telling Terraform, you can communicate with me on this port. For Mac and Linux, you're going to get a domain socket. Once it's worked that out and opened that method of communication, it gives that info back to Terraform. And from then on, any time a resource needs that binary, it will use the communication method given to it. So now we have the core concepts, and we know what we want to do. How do these map? So taking our diagram from earlier, we have a plugin. A plugin is going to be for vCloud Director, the whole thing. Resources are your individual components, which you can control. And then your schema are contract defining rules when interacting with these resources. So let's look at the schema that we needed for a provider. On VCD, to connect, I needed to hand over a user, password, org, a URL, and a VDC. Now, a VDC is just a virtual data center. The last three of those, well, actually all of those, are going to be given to you by your hosting provider. So let's look at an individual schema. User, for example. So when defining a schema, you're not just saying a field that you expect. You have to describe that field. So we have value type, description, default value, and possible flags. Now these flags can be optional, required, computed, or force new. The last two are mainly going to be used for defining resource schema. As computed means this is something that my hosting provider's API is going to give back to me. And force new says, if this changes, destroy what's there, create it again. It's not something that can be updated. So in the case of our user, we have value type as type string, description, VCD username, and required is true. We can't actually try to make a connection unless this has been provided. When looking at resources, as I described before, we want network, vApp, firewall rules, destination NAP, and source NAP. Each of these resources, as well as having schema, will also define how they do standard CRUD operations. Each of these are required other than update. If you have defined your resource schema with every field being force new, you've said there's nothing that can be updated, so you don't need to provide an update function. But Terraform provides one more. Exists. Exists allows you to check that what you're trying to create isn't already there on your hosting provider. Because what you need to remember is Terraform may not be controlling every single resource you have in that hosting provider. People can create things manually. Maybe you're using another tool to create them. And you don't want Terraform to try and overwrite that, to fail with an error. So let's have a look at how we would define this in Go. So this is a provider, as we mentioned earlier. You have a string of schema. And here we show user, password. Once again, both of them are of type string. They're both required. And we have a short description. After schema, you create a resources map. So these are the resources that this provider should handle. It's a standard map with a string, and then the function that we're going to call if this resource is used. Some of the issues you may encounter when writing this is not every hosting provider will have a standard REST API. You may have things that you can't update, which was actually our case. So we were trying to work with firewall rules, and VCD allows you to create, delete, nothing else. If you try to update, it's just going to recreate. One of the things you need to remember here is this is all written in Go. This is a really, really good programming language. If you need to do extra logic, manipulation. You can do that before you send anything onto your cloud provider. In conclusion, writing a Terraform provider is really simple. The framework is there. Everything is well documented, and there's already lots of community code. It's very easy to read through. Also, don't let Go put you off. Even if you're not a Go developer, it is very, very easy to pick up and very hard to master. And also, the community support is great. As soon as you get something out there, you're going to have people helping you, working with you. And the Hashicorp guys gave me so much guidance when I first issued my pull request, so thank you. Are there any questions?
So if anyone's got any questions, I'm happy to send the mic round. We got should we take?
So just in case other people don't know, vCloud has a concept of a template and a catalog, but you didn't mention that as part of your model of a VApp. So how are you running a virtual machine or a VApp when you aren't caring about those things?
I try to keep it fairly high level. If you look at the documentation, the VApp, when you describe it in Terraform, you actually say where the catalog is and what the VApp template is that you're hoping to call. It won't create those.
Any more questions? Back here. Any more at all? Great talk. How do you go about testing your provider plugin?
Good question. Terraform makes it quite easy to test your Terraform provider. What you would write, you don't actually write unit tests. Everything is an acceptance test. And they have provided a really good framework for doing that. So one of the things you do when you write your provider plugin is you allow a default function to get your values. This allows you to write code and test it without having to upload your credentials, because you don't want to do that. So there is a really quick framework, but it is all acceptance. So you can only run tests on something you can communicate with. But that was beyond this talk. It's right there. It makes it very, very easy. You just say a test resource that you want to create, and then you test that that resource is as you have defined it.
Anything else at all? While I'm looking, Brett, I'll just ask you, now that you've written one provider, do you think it'd be much easier to write another one?
Yes. We've actually started working on another one.
Anyone else, though? If not, I think thank you very much, Brett and
Thank you.
Nikki. Thank you.